How would you design ChatGPT? Hey everyone, welcome back to another Exponent System Design mock interview. My name is Kevin Wei and we have a very interesting ChatGPT system design video for you guys today. Now, before we get into that, Neeraj, our guest, do you want to say a few words just to introduce yourself first?
Sure. Hey everyone, my name is Neeraj Gupta and I've been having more in the software industry for more than 16, 17 years and engineering manager, taking a lot of interviews, system design, coding and all, but definitely excited to give this mock interview today.
Absolutely. So here's the question. How would you design ChatGPT?
Definitely, that's a very good question and kind of a trending topic. Let me just kind of start with some kind of functional requirements. Let me just brainstorm a little bit. So designing ChatGPT, right? So ChatGPT mainly, there is a user who is interacting with the kind of bot that is going to be giving answers to different questions. So a user can probably start with creating a conversation, updating by maybe sending a message and expecting an answer from the ChatGPT, that system. Then it can be like viewing the conversation or mainly deleting the conversation. So that's about the conversation. And there is one more operation, like if you don't like the answer, or if you do like the answer, I mean, you can give thumbs up and thumbs down. You can tell whether it is good or not. So here, I mean, that functionality we can provide, and even that can train the bot on the backside. What do you think about these functional requirements? What do you think? Is that good enough, or should I think about more?
I think this is good enough. This is good enough for like a MVP version of ChatGPT. So let's see how these come out.
Yeah. Before I go to non-functional requirements, let me see. So I can send a message. Does that message is only text-based, or can it contain images and all as well?
Yeah, I like where you're thinking here. Let's just assume for this system design video, we're just going to constrain this to text inputs to ChatGPT.
And any language preference, like just English enough, or?
Just English.
And if I do thumbs down, I think maybe I'll consider it might train the model. So that's fine on the back side. But yeah, let's jump to non-functional requirements. So there, I mean, one thing is latency. I mean, when I send a message, the time it takes for that ChatGPT to respond back with an answer. I mean, I've seen it taking even 5 seconds because it does a lot of processing. Are we okay with that slowness, or shall we work on optimization?
Yeah, that's fine. That's fine for this one. If we have time later, we can talk more about how we might optimize the latency.
Sure. I think the other things is security, like login flow. We can have then rate limiting. Mainly the standard one to prevent DDoS. The other important one for ChatGPT is a user can send a lot of messages to ChatGPT at the same time, and that can bring down those servers. So the rate limiter should consider those part. Then definitely scalable, the way that ChatGPT has trended. Even if we assume, let's say 10 million users a day, then 10 million users sending average of 5 conversations. Here, let's say 5 conversations. They're creating maybe even asking 4 questions. I'm just doing some kind of estimation to figure out how much scalable that architecture should be looking like. So it's like 4 questions, 4 messages I'm sending, and I'm getting 4 responses. So it's like 200 million. Okay, that's a lot messages per day. So obviously this is a lot of requests. Like if I'm sending a request to the server for 200 messages, it's a lot. I need to consider like load balancer here in my design and all later on. And that's about the server. Like number of requests. Then even if we talk about the storage, storing those 200 million messages, even if I assume 100 bytes as a message, although I'll estimate later on, but even that will give probably 20 gigs per day, and for entire year 365 multiplied by this is like 7.3 terabyte per year and 73 terabyte for 10 years. So yeah, obviously we have to think about a pretty good scalable database over here. I mean, we can go with NoSQL with that supports proper sharding and all, but let me go over that in the high level design. Do you think these calculations sound reasonable?
Yeah, this is reasonable. I like where your head is here, right? So you're starting off thinking about the latency, security, scalability requirements. This all sounds fine to me. Let's move on to the high level design and see what that might look like.
Okay, so let's see if user, I'll open, okay, there is, yeah, user, let's say user. So there is a user, then the way, I mean, I'm just thinking about the flow of sending a message or some kind of conversation handling. So this user, if they send a message, let's say, so the way I would consider it is mainly some kind of experience layer, I would say. That's usually useful for orchestration and making sure that if there are multiple devices, native, iOS, Android, desktop, web, MWeb, so we can provide some consistent user experience to the users than writing everything from scratch, plus orchestration. So let's see if I am sending a message here. So maybe is this good enough or zoom?
Let's see, maybe you can zoom in a little bit.
Okay, that's fine. So I'll keep it here. So here, yeah. Let's say if I send a message here, then I would create some kind of conversation service. So conversation service is like those requirements that we discussed, creating, updating, viewing, deleting. So here I'm talking about sending a message. So it will relay this message to that service. Then this conversation service, now one important thing is like you can send anything you want to ChatGPT. So we want to make sure that we first sanitize the input, and so for that I would create some kind of machine learning model and expose it through some kind of API. So maybe some kind of profanity API I will create, which can detect like obscene text or maybe insults or threats. Like people even give threats to ChatGPT and all. So we should be ready with the standard answers for those and able to detect them. So it's mainly kind of we are sanitizing. So this API will call the profanity model, I would say, some kind of machine learning model. There are pre-trained models, or I think we can train with our data set as well. There are models like FastText provided by Facebook and multiple other models that help in profanity detection.
So what you're saying here is that for a subset of the inputs from the user, we just won't even send to any of the other downstream services. Like if we deem that it's just obscene or an insult to ChatGPT or something like that, where there's no value in sending it to our downstream systems, then we're just going to give some generic response.
Yes. So we don't need to get answer in that case. Yeah. So that's why we want to sanitize it by calling this model. And so I would sanitize it first and give a response if needed. Then if it is sanitized properly, like if we think that it is really good question, so I'll call a service which is the ChatGPT. It is also powered by machine learning. So this is another API that I'm just using the word API or service, I'll say here. So service I will call, that is also calling a ChatGPT model, which is the core, which is the kind of meat of this this functionality, this ChatGPT ChatGPT system. So that model, so I'll say that this is the question. So I'll send this question, then this question is relayed to model that responds with an answer, and that answer, after that conversation service gets that answer, it will store to, I would say, a database. I'll create a database here. So database, So I'll store the results for what that model responds with, and I'll save it in the form of that conversation. So the conversation, the way I'm imagining a conversation, so there is a, like, you can create multiple conversation, and each conversation contains a bunch of messages. Some of the messages are your questions, some of the messages are responded by the ChatGPT, so those are the answers. So that's why those, whenever they respond, we will store both of those conversations in that database. So it will be add that to DB, that message, and link it to the conversation. So that conversation is provided, and after that, that result will be sent back to the user that you will see on the screen. So this is rough design about how it will work when you are sending a message, and viewing it should be relatively simple. Like, you just go to the conversation service, get that data out of the database, and view the conversations. Then deleting and all should be relatively simpler. I think the complexity we can discuss the thumbs up, thumbs down use case, let's say. So if somebody gives a thumbs up here, so let's say thumbs up, thumbs down is much better. So because thumbs down is more complex, I would say. So if we say, if somebody gives thumbs down, then it will go to the conversation service again, and yeah, let's see here. So it will go to the conversation service saying that it is somebody has given thumbs down. Now that thumbs down, there are multiple ways. There you can ask user, if you are giving thumbs down, what answer you would provide. Like, you are not satisfied with the answer, but what kind of answer do you think you will be satisfied with? What is wrong with that answer? So we can provide that kind of functionality to the user, and that can be sent over with that thumbs down request as well to the service, so that that can be stored, and that can be used to train this model as well, the ChatGPT model, because ChatGPT model will be continuously learning. So with that thumbs down, one way is we can send a service through the ChatGPT service and trains the model, but many times it will take some time, a lot of processing will need. So one option is you can create some kind of Kafka queue, or some kind of job where that data is offline processed, and ultimately this model is going to be trained based on that thumbs down or maybe the new answer. So the other thing I think I missed is, okay, so there is an option, there is a possibility that a user, I mean, I'm kind of a malicious user, I don't want ChatGPT to perform well, or if maybe I'm just playing with it, so I can thumbs down it again and again. That kind of approach, that kind of malicious activity should not impact the model. So for that, I'll create some kind of another machine learning model called risk model. So where that will tell you how good of a user, how risky that user is. So I can go into more details, or I can switch to maybe more details about conversation service and database.
Yeah, I think this is good for a high level introduction. Thanks for that. I would love to dive a little deeper into the conversation service actually.
Okay, so from conversation service, let's see if I can create some kind of table here. Let's see. So, oops. Yeah. Okay, so let's see. So I'll have let's say maybe operation. Let's see the conversation service. I'll create a bunch of REST APIs in that conversation service where we have operation and I would say URL request, and I'll have response as well. So like operation, if you are talking about, let's say, delete, or let's say create a conversation. So create a conversation, I would add this, probably delete view a conversation, and then what else did we have? The thumbs up, thumbs down. So maybe I think there was another one that we had, right? Create, view, delete, and send message. Yeah, send message. So here I will have something like probably, so creating a new conversation. I'll just create a new conversation by post. So ChatGPT v1/conversation. So here I need to provide, okay, with what is the title of the conversation. So I'll have some kind of JSON request where I'll provide the title. I'll provide, I mean, it will take automatically from the user token, it will take the authentication token and identify who is the user. So then so that's the one, and it will respond with 200 and those kind of status codes it can respond with. Then deleting, I'll just use the delete keyword. I'll have a conversation ID for each of the conversation. So in this response, that conversation ID would be returned. So that can be a GUID also. GUID is, I mean, kind of random number. So that is unique, probabilistically. And then we have like for deletion, I'll select that particular conversation to delete. I'll have that and respond with, I mean, I can say 204. Also, it's no content, so I don't need to return any content. For viewing, I'll use the get keyword and I'll have that conversation with what that particular. So this will return the list of messages in that particular conversation in the ordered manner. And then if I'm sending a message, so sending a message will be part of the conversation. So in that conversation, I'll send a message here. So maybe message, I'll post a message in that particular conversation with the message. I would say content, it can be type also in future if we are expanding to images and all, and then parts also if it is media data parts, but right now it is just text. So right now it's going to be text only. So text I'll provide. Then yeah, so thumbs up, thumbs down, that also happens at the message level. So I'll have for that conversation, for that message. So this, when I am creating a message or sending a message, it will return the message ID also. So that can be in the form of grid, or I mean, we can think about a different ID number generator. There can be various ways to generate IDs, but here if we have a grid, then for that particular message I'll have some kind of probably rating or something like that. So that will indicate in the request, I can mention whether it is like, okay, operation is or rating is up or down. So or down, maybe something like that, and I'll respond with the appropriate HTTP status codes. So there the messages will be having, I mean, user as user ID, or maybe system. The system generated messages will have user as a system, but I mean, I can go into more details if you think. Okay, so let me share how the data would look like in the database. So as I mentioned, as we discussed up here, that it's going to be 73 terabytes. It's going to be huge. And then I think here services would be, there will be load balancer that we discussed here, but anyway, from data perspective, 73 terabytes. I would go with some kind of NoSQL database where let's see, that one, I mean, either I can go with DynamoDB that provides that scalability, Cassandra. So anyway, I mean, I can go with some NoSQL databases, but the way I would structure that is mainly like here, let's see if I'm creating some kind of table, a small table. So a conversation contains multiple messages. So I'll create some kind of probably conversation table or so. So where we'll have conversation ID and kind of a list of messages ID. So if we are going with like any kind of SQL, so we have conversation, but I think I identify it by the user also. So it will be mostly kind of user conversation, because a conversation is totally tied with the user. If I'm creating conversations, so I'll have a list of conversations for myself. So I can have, like, for my particular user ID, I can have a list of I would say list, or that can be formulated in the form of JSON in NoSQL databases. So with the conversation IDs, so some kind of integer I can have, or long, it's going to be good, right? So some kind of list with conversation IDs. As I mentioned, that can be serialized into JSON. So then these conversation, for each conversation, if each conversation will have multiple messages, so it will be something similar format. And if I look into the message, like how a single message would look like, so message, I would say in terms of message, it will be some kind of message ID. I would have field, some kind of text. So message text, we will want to know whether it is, who is the author, whether it is system generated message, which is the answer, or whether it is user ID, user generated. So then there is a concept. I mean, we don't need it immediately right now, but we can have, like, that conversation we can think about in the form of a tree, where, I mean, there is a parent for each message. Like, you asked a question, you got that answer. You asked a follow-up question, you got another answer. Then you suddenly changed the topic in that same conversation. So we can configure that parent. I think it will get complicated right now unless you want me to get into more details, but mainly we can create a parent as well, for which will tell you what was the previous conversation for which we are responding. So that's kind of rough idea. I can go into the model right now, and maybe we can discuss this in more detail later. How about that?
Sure, yeah. Thanks for walking me through that. Yeah, let's talk about what this actual ChatGPT model will look like.
Okay. So so for ChatGPT model, let's see here. So when we send a message, when we send a question and get answers, so there is one straightaway thing that comes to mind is supervised learning, where we can have a lot of labeled data set. We can have a list of questions, list of answers, and train a model based on that. But really, there can be so many combinations of questions and answers. Even if you want to figure out about system design, there can be question like, what is system design? How is system design useful? Explain system design. And why do you want system design? So even asking similar question, there can be so many variations of questions. The answers, okay, when you say what is system design, it needs to explain what it means exactly. How is it useful? It needs to focus on the uses of it. So even the combinations of answers and all, it can be pretty, like, a lot of combinations. And getting that data set to train is really very, very difficult. So because of that, I wouldn't use supervised learning as such immediately. But what I would do is I would have some kind of transformer model, GPT transformer model, where I'll have access to the common crawler data. So which is mainly let's say we are crawling the list of websites over the internet. So that will give you so much data to train. And we can even add books here. We can add Wikipedia links, which comes in kind of crawler data. We can even add codes, like ChatGPT handles codes, right? So you can say find a bug in Python code. So those kind of things we can train, like we can just add there, and that transformer model, what I would do is, it will not respond to question and answers, but what it will do is it will predict the natural sequences of words. So like if I say what is system design, okay, or maybe if I say system design is, okay, so then what can come next? So there can be multiple things that can come. So let's say system design is about planning and creating architecture. So it can be meeting requirements. So then it can be designing services. It can be about designing databases. So there can be many solutions that can, many phrases that can fill that sentence. So my first step would be creating such kind of model which finishes those sentences, completes those sentences in a natural language, which are grammatically correct and semantically meaningful as well. So, but the one thing to notice is, I think, how do I get, like how do I select out of these four, which one should be the next, like system design is, out of these four, these are the possibilities based on the training. How would I select these, which one is the one that should be returned? So there are multiple approaches there. There are multiple approaches, like there is top K, there is greedy. Let's say I'll have probability, I'll create a probability of these. Let's say there is 0.32 probability chance of this one returning, or maybe 0.25 for this one. So maybe 0.10 or 0.09, and rest of them some lower priority probabilities. So one option is always return the most greedy one. So planning and creating architecture. But the challenge is, if we have awesome, which has probably 0.34 as a probability, then this is not the what I want. I don't want to hear the system design is awesome. I want to understand what system design is. So that's why there are ways, like instead of greedy, we can use some kind of top K method as well, top K strategy, or nucleus temperature. There are multiple strategies. In top K, you can select like some top 3, let's say top 3 if we say, so I'll select top 3 and randomly pick from one of those as the answer. That's the reason why you see that if you send the same message to ChatGPT, it can return some other reply back. So anyway, there are different strategies, but mainly, in short, we are finishing sentences with this model. Then after getting that, then I have a lot of data already trained. My next step is to make sure that that model is trained to answer the questions. So for which I'll do some kind of supervised fine tuning. Here I'll get some kind of data set and train this particular model with questions and answers. It doesn't need to be fully like I mean, it needs to be a decent size, but yes, there are still limitations because we cannot have all kinds of questions and answers that we can train. So here what I would do is, here I would mainly kind of collect training data, train the model in the form of question and answers. So that I will do. I can go into more details, but let me go to the next step here. So even after training the data, right, it is possible and it is highly likely, because training is because of the number of combinations. So what I would do is I would create some kind of reward model also. So when we think of reward model, so after training this, even here, if we take this model into account, so what I would do is I would pick some answers from the model. So I'll pick answers and I'll have like AI trainers or people like us, annotators. We will decide which answer is good. So here, let's say if we ask a question, what is system design? And we get multiple combinations. Let's say here, So this is not training data. So if I ask a question, what is system design? And I get multiple answers like system design is, I'll not write it everything, but system design is planning and creating, and all these answers I get. So now as a user, I know what I'm looking for. So I would give some kind of rewards to each of them. So I can have some kind of, there is something called Likert scale. It can be in the form of 1 to 7 or 1 to 5. So I can give a rating in the form of 1 to 5 or 1 to 7. That will tell you, like that scalar value will tell you how good that answer is. So based on that answer, right? So based on that answer, so I'll put it in that reward model and train that reward model with these two. Okay, training data, using training data and training that supervised fine tuning model and reward model, I'll create the final version using reinforcement learning. So reinforcement learning is very interesting, where we train kids to walk. I mean, it takes into account these fine tuning and reward model. So we know about kids, right? They start walking, they fall down, they learn that, okay, if they move this way, they will fall down. They learn it because they are getting a reward from the environment around, whether it is negative reward or positive reward. If they fall, that's a negative reward. If they are walking, we are clapping for them. That's a positive reward. Similar way is how we train robots as well. So these, they are walking, they hit some system, hit wall, they can avoid staircase. All of them is based on what reward they are receiving from the environment and continuously training them. So that's the way, that's the approach that I'll use here. I'll use the trained data and reward model here. So using that trained data, I'll initialize something called PPO policy is what we say. So that PPO optimization, it's, then I'll take one question, go through reward model. So using PPO optimization, I'll use this fine tuning model into PPO optimization and take one question at a time, go through the reward model, get the reward, update PPO, that again, update again, PPO, go through the same process again, take another question and continuously learn and learn and learn. So with this, all this approach, even if in the beginning we didn't have that good of a data set, that good of a labeled data set to train that model, we will still get pretty accurate result set in the form of like natural language response from the natural language, from a human language or natural language question. So does that answer your question? I think another important one is, yes, I mean, these emotions and all, right? This reward model, we as a humans know the emotion, the tone of what people are asking. So that is taken care of in the reward model also. In the Likert scale, we will ask questions like, okay, why are you rating as 1? Does it contain profanity? Is the emotion or the tone not correct? Or is it not natural? So based on that also, that reward model will continuously train itself.
Absolutely. And as you were explaining the whole thing, I was smiling because I feel like this is like, honestly, we can probably do a very deep dive on many different parts of this design, but I just loved how you broke it down into these different aspects, and I felt like this was a really nice way for us to see how ChatGPT is built, or it could be built. And yeah, I mean, honestly, this was a great system design video. And I know that we're short on time, so I didn't want to cut you off here. Again, thank you for your time, Neeraj. Was there any like final thoughts that you wanted to share before we wrap up the video?
No, I think definitely this ChatGPT is doing great, and excited to see and excited to learn more about what's going to be next. I think they have started supporting images, videos, and yeah, it's going to be fun.
Yeah, and inputs, images, audio, probably in the future, outputs that include like audio or images, videos, lots of amazing stuff, very green space. Neeraj, thanks for this awesome overview. And for the audience who are watching at home, if you get an interesting question like this, hopefully this is helpful for your system design interviews. And good luck with your upcoming engineering interviews.